You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views, and insight into the creative world of technology and the people that make it happen. Adapting industries to and preparing them for a warmer world will be essential for the future successful functioning of societies of all nations, said Dr. Tim Fox, co-author of the IMechE's latest report on climate adaptation, published in April this year. The report, entitled Adapting Industry to Withstand Rising Temperatures and Future Heatwaves, was produced in conjunction with the IMechE's process division and a plethora of leading climate change and sustainability experts from across the globe. While many engineers are working on technologies that will help mitigate the climate crisis itself, authors Dr. Fox and IMechE Policy Advisor Dr. Laura Kent believe that more should be done to prepare industry for future climate change-induced heat-related impacts. Their work demonstrates how increases in ambient temperatures and more frequent, severe, prolonged heat waves could have a devastating impact on industry and its workforce. They outline the urgent need for engineering-related standards and design codes to be based on expectations of future climate rather than past climate. Adaptation solutions to be sustainable and result in net zero greenhouse gas emissions, and strategies to be developed to make workplaces and working practices comfortable and safe. I had the pleasure of speaking with Tim and Laura about the Climate Adaptation report and discussed with them their reasons for bringing together such an international team of experts to advise on its content, what adaptation technologies engineers are developing, and how, as a leading voice in policy, the IMechE could galvanise political change. Tim Fox is an internationally recognised expert in climate change mitigation and adaptation, with specialist knowledge of clean energy, sustainable cooling, process engineering-based industries and sustainable food systems. He's a chartered engineer and fellow of the IMechE and the immediate past chair of the Process Industries Division. Tim represents the IMechE on the UK Infrastructure Operators Adaptation Forum and is a member of the Adaptation to Climate Change Group, a BSI committee. Dr. Laura Kent joined the IMechE in June of 2022 as a Public Affairs and Policy Advisor. Prior to joining the institution, Laura held roles at the Government Office for Science and the Department for Business, Energy and Industrial Strategy, working on policies and advice to support innovation in the UK. Before starting a career in policy, Laura was a scientist at the National Physical Laboratory. I began by asking Tim what his motivations were for producing this report. Tim and Laura, thank you so much for joining me on the podcast today.
Oh, thanks very much, Helen. Yeah, it's an absolute delight to be here with Laura.
Tim, as I mentioned in my introduction, you have had a long career in the environmental and energy sectors and are recognised as a leading voice on engineering issues related to climate crisis. Can you share with us what the drivers were for the latest IMechE report on climate adaptation and what message you were hoping to impart in producing this piece of work?
Yeah, to start sort of at the beginning, as it were, Helen, I've been working in climate change adaptation now for about 15 years. And when I started working in the area, there was very little interest in adapting society to meet the challenges of future climate change. Yeah. Everybody was focused at that stage on reducing greenhouse gas emissions, quite rightly. But it was clear that in addition to doing that, we were going to have to do something about preparing society and adapting society globally to the temperature rises and climate change that we will experience as a result of the emissions we'd already put in since the beginning of the Industrial Revolution,
Sure.
and the emissions we were going to make as we were transitioning to a lower carbon future. And in recent years, we've seen an uptick really in the amount of interest in adaptation. It's certainly moved forward dramatically in the last 5 years. And I think that's really as a result of the fact that it's become increasingly clear that given the current policy commitments, we're not going to make the 1.5 degree centigrade target set by the Paris Agreement in 2015, and possibly not the 2 degree target, without some absolute radical transformation in our policy landscape and the pace and acceleration of that transition. So, sort of in recognition of that reality, adaptation has risen up the agenda, and in terms of that as a background context, what we've seen is a lot of work on adaptation in the area of flooding. So, flooding has had a very high profile, and I think that's quite understandable when you see you think about the public awareness of flooding. It has an immediate impact. It's very tangible. It happens quite quickly often, and has quite devastating consequences for the people flooded and the broader sort of community and then nationally. So in countries all over the world, we've seen an increased focus on flooding and what we need to do about responding to that, and also some increased interest in the impact of more intense storms, particularly hurricanes, typhoons, cyclones, these kind of extremes. But there's been very little attention paid to heat. And to the impact of rising temperatures. So specifically, the rise in the seasonal ambient temperature, so the sort of the constant background temperature going up from year to year, across the seasons, and then more particularly extreme heat events such as heat waves. And so, really, what I've been looking to do in recent years is to develop a much more focus on that area and to increase awareness and our knowledge base on that. Now, within that area, there's been quite a bit of work on heat impacts on energy systems. The energy sector has, in many ways, been leading the charge on how we respond to extreme heat on the electricity distribution system, for example, and electricity generation, particularly in sectors like the nuclear power sector, where there's a large reliance on cooling from coastal cooling waters or river waters, and the effect that raises in temperature, particularly in river waters, have on the ability of nuclear plants to cool themselves. So quite a lot of work in the energy system, and a lot of work on buildings, particularly domestic buildings. And again, like flooding, you can understand the focus on that, from a public perspective, and the wider built environment. And again, a lot of that has been driven by the urban heat island effect, which we can probably come on to in detail later. But the fact that inner cores of cities are much hotter than the rural hinterland that surrounds them. So quite a lot of work done over the years on that, but almost no work done on the impact on industry. And this was really of concern to me, because I wanted to highlight that industry is at the core of the sort of economic well-being of all nations around the world that have industrialized or are industrializing, and it's really remiss of us as a broader profession not to have an understanding of what the impacts of future heat extremes and this sort of slow but sure increase in seasonal temperatures will have on the ability of industry to perform its role within society. So when I became aware of this, what is effectively a gap in our knowledge base and our awareness, and indeed in our professional practices as engineers, I looked to fill that gap, and that gap clearly aligns with the core role of the institution.
Yeah, of course.
So raising awareness, developing an evidence base, and improving professional practice is sort of at the core of what we do. And the need to raise this issue of what these impacts are going to be on industry aligned very well with that. So that was the background to the sort of core drivers of the report. And essentially 2 years ago, we started the project, and with bringing Laura on board as a co-author to that to the report, accelerated our activity in that area. And so, I'm pleased that we managed to publish that earlier this year.
Yeah, I was at the launch event for the report, and it was a fantastic opportunity to hear the issues surrounding, as you've rightly said, we there's a lot for us as engineers to think about, isn't there, in terms of how we address our working environments, and what we do to try and adjust and adapt to the growing issues. We don't want to be part of the problem, essentially, do we? we need to be addressing it.
Yeah, absolutely, and I think it's it falls upon us to raise awareness of these issues, both for the profession and to government and to society more broadly, when we become aware of these issues, and effectively to search for solutions that, as you say, don't make the situation worse.
Yeah. Laura, the report clearly reflects the views of many leading experts in the fields of energy use, and climate adaptation. How do you work with such a prestigious group of people to identify the key issues and topics and get their consensus?
I think part of working with such a great group of experts is really what makes my job so fun and amazing and why I love what I do. So I think the key thing really is to make sure we have a comprehensive analysis of the issues at hand. So what was really exciting about this report is that we had experts from around the world contributing. So it wasn't just a UK focused report, it's really relevant globally. So the first thing we set about doing was understanding what we wanted the report to cover, because obviously it's such a big topic. We could have gone in so many different directions, that we had to really make sure that me and Tim both understood what the scope was and start to identify those experts who we could reach out to. And then we split up the workload. It sounds really simple, but we split up the workload. Sometimes it was a one-on-one conversation with either myself or Tim to gather information with these fantastic individuals, or we invited them to write a section based on their expertise. So we had really a collaborative approach to writing the report. But I think one of the basic things when writing any report is to make sure we had a data-driven approach. So we had a comprehensive literature review to provide a solid foundation. So when we were dealing with complex issues, we understood the topics. This was particularly important for me because obviously I was new to it. Tim's an expert, and I needed to get up to speed pretty quickly. But thankfully, Tim is just very knowledgeable and very patient and very kind, and took the time to bring me up to speed with a lot of the topics. We were open to new ideas and suggestions from our contributors, so we can really understand their research, their experiences, their observations, So we had a platform where everyone was valued and we were transparent and inclusive in what we were doing. In terms of finding our fantastic group of experts, we both reached into our networks to find stories of how companies were adapting to warmer temperatures. We spent a lot of time researching, doing things like listening to the relevant podcasts and webinars, and then reaching out to those experts and talking to them to get more details. So in the report, we have a big case study on what happened in Canada in the 2021 heat dome, and how that impacted people and what the local governments are doing to react to that. And a lot of the contributions we got for that section came from listening to a webinar, and then we just reached out to those people and saying, oh, this is really interesting. Can you expand on this? And what do you mean by that? And it gave us a better understanding of the issues. So yeah, for the report, it really helped that we had this clear plan of who we wanted to talk to and which one of us was the lead author on it, who was contributing to those bits and what those deadlines were. And I think that's really important. It sounds really boring, but it's a really important bit, I think, of report writing, because we could confidently go off and talk to our contributors and get on with writing, knowing that we had a clear plan on what the expectations are, and people just knew what was going on, and we weren't being back and forth being like, I think the date's this, or that I think it needs to be done by that time. I guess culture of respect, open communication, evidence-based, as you know, are the solid groundworks of a successful report, and building that consensus. And I guess also I just want to really say, I think I may have said it already, how thankful I am to each and every single one of them, because it was a lot of effort, a lot of time committed. And I don't think we would have had the impact with the report that we've had if it wasn't for each of them. So yeah.
Yeah, it definitely helps, doesn't it, when you can bring a community like that together, especially an international community, as you've got with this report, and be able to find common ground, so that it gives strength to the arguments and to the recommendations of the report, doesn't it?
Absolutely, yeah.
Now, you touched on there, Tim, about storms and bad weather, and only a week ago we saw the impact of Storm Babbitt on the British Isles, and flash flooding, certainly where I am in Lincolnshire, was quite severe. Elsewhere around the globe, we're also witnessing these extremes and prolonged heat waves. I think most of our listeners will be well aware of the societal impact that these events are having, Tim, but how does this affect industry? You know, what cost is it having on manufacturing, for example?
Yeah, so there are basically two elements to that, Helen. The first element is the sort of sharp element, as it were, and that's the issue of safety. So ultimately, our prime concern has to be for the safety of industrial plant equipment and the workforce that are operating the facilities.
Yeah.
And then the second element, which is related to the first, is the issue of productivity and the implications that has for local and national and global economies. So maybe the best thing is for me to sort of take those two in series and highlight the linkage between the two.
Yeah.
So on the safety side, there are two dimensions to that. One is this constant increase in the seasonal ambient temperature. And then the other is this future projection that we're going to see in many, many regions around the world, an increase in the intensity of heat waves, so the temperatures to which they go, but not only that sort of peak temperature being an issue, but also the fact that heat waves are going to be more prolonged and more frequent.
Yeah.
So within the industrial setting, clearly we need to be able to cope with that both at a safety level and a productivity level. So within safety, if you think about any industrial facility, be it a factory or something much bigger, an oil refinery, for example, or a gas processing plant, there's a plethora of processes and vessels and machinery that are affected by heat, and in particular by those extremes that will be experienced in high temperature heat waves. And this can lead clearly to the sort of overheating of equipment, machinery, and pipe work and things like this that can lead to either to the spontaneous outbreak of fires. If you think of electrical equipment, electrical cabinets getting hot, and they can lead to fires in factories and within plant. But of course, if you've got pressure vessels involved in the process, then these pressure vessels will overpressurize more readily than at lower temperatures. So this then means that pressure release systems come into play, and if there are hot gases associated with those, then there are risks for the workforce working around the facility in terms of being impinged and impacted by those. Then, of course, there's also the general question about the sort of the environmental impact of what's being released, both in terms of its effect on the workers and the local environment. If you think about feedstock materials or finished products, depending on the way these are stored, these have been known to spontaneously combust during extreme heat waves and again start fires because certain things reach that critical flashpoint temperature and ignite, and that's an area that causes some considerable safety concern. Because if you're in an enclosed factory environment within a building, then you've got all that machinery producing a lot of heat, which again can have implications for the safety of the process. And for example, in a mining environment, a very closed environment, the high temperature combined with the friction heat that's generated, for example, on pulleys and belts and conveyor systems that are moving the rock around the mine, can lead again to the outbreak of fire. So lots of safety issues that are our sort of primary concern when temperatures rise within plant. And of course, the impacts of any of those safety incidents on the performance of the plant can be quite significant. So plant can be severely damaged. They can be temporarily shut, or indeed they can be shut down for prolonged periods as a result of the damage that occurs from those fires, or the impact of a serious accident with a member of the work team. So, there's implications. There are the safety implications per se, but there's also those implications then on productivity. So then coming on to productivity, there's the area that Laura explored in a great amount of detail, which was the impacts of these temperatures on the workforce, on the workers in the factory or around the plant, and the way in which this can affect their productivity. But of course, the equipment within the plant will change its performance. Yeah. So even if it doesn't reach those safety thresholds where the safety becomes an issue, the performance of the process, the chemical process or the mechanical process, will be impacted by extreme temperatures, and indeed year-round by changes in seasonal temperatures. And this can affect the production rates, production volumes in all kinds of manufactured and broader process plants. So there are these issues around productivity. Now, once these productivity issues become significant, then clearly that impacts on the local economy. Yeah. It's affecting the performance, the economic performance of the business, and that can scale up depending on the scale of the industry. That can scale up to have national and even international impacts on sort of the global economy, national economies, and that's very much the case in the developed developed world, the fully mature economy world of the UK, United States, etc. There's a global north, as we call it now, and the developing economies in the global south that are relying on a broad range of industries to help pull their economies out of poverty and lead to development, meeting development goals. So, absolutely critical that we get that right. Now, you asked about costs. Very, very difficult, as you can imagine.
Yeah, of course.
To pin down exact costs, and of course, there's more work being done. As I said initially, there's been hardly any work done on just the sort of engineering and technical aspects around what we have to do, let alone the economic and social issues, the implications that all of this has in terms of the impact on industry. But broadly speaking, the sort of global cumulative losses, for example, there is one piece of work that showed that between 1992 and 2013, so a little out of date, but still relevant, because the situation has simply got worse. The global cumulative losses can be anywhere, from heat extremes.
Yeah.
The global impact of temperature excursions beyond what might be expected, somewhere between 5 and 29 trillion US dollars.
Wow.
Now, I know that's a big range, but if we're at the bottom of the range, 5 trillion is a pretty big number. And if we're at the top of the range, touching 30 trillion is enormous. And within that, there's a real big issue around disparity, because what we find is that within the, what's now called the global north, the impact on GDP is relatively low. One estimate is around 1.5% of impact on GDP from these sort of heat extremes, whereas in the global south, in the developing economies of the world, it's closer to 7%.
Yeah,
the impact on the GDP loss. Now, this will only increase in future, and those disparities will widen simply because those countries don't have the capacity necessarily to undertake the adaptations that are needed and the building of their capacity for resilience.
Yes,
to be undertaken. So that's one kind of, if you like, sort of broad global view. Now, just drilling down a little bit into some areas that people may not have thought about, but this has a huge impact on insurance losses, for example.
Yeah, of course.
We've already seen within the insurance sector, and they've been thinking about this for some time. The impact that flooding has and increased storminess is having on their industry, and what that means in terms of the sort of premiums they have to charge, and the and whether they take on what they might consider high risk scenarios or not. And just looking at the heat related losses that are becoming more acute, and we've certainly seen that in recent years. Insured losses in the 5-year period up to 2022 were estimated at around $46 billion US globally. Wow. And that was up from 30 billion in the previous 5-year period. So as we see these, the more frequent and prolonged and higher temperature heat waves occurring over time, these losses simply go up. So the economic, the sort of the costs, and then the translation of that into the sort of the broader economy are quite significant and are set to become even more significant.
Yeah, I mean, just that cost that you described, I mean, it's beyond imagining even now that amount of money in terms of the losses associated with industry and the failure of industry and its supply chain to be able to produce goods. I mean, it's just beyond imagining, really, isn't it? And it's only set to get worse.
Absolutely, and it kind of underscores the importance of this broad range, this broad industrial base that we find in developed and developing economies around the world. The importance of that that sits within their economies and the global economy, and certainly all the projections into the decade, the years and decades ahead, are that these heat waves are going to become more significant in the sort of suite, if you like, of climate change impacts.
With increased temperatures in the workplace, Laura, companies are really having to seriously consider the way that people work. How are companies addressing this problem, and what methods and tools can they use to ensure the safety of their workforce?
Yeah, I think that's a really interesting question. And I think what a lot of people are starting to understand is how heat is impacting us on the way we work and the way we function in society. So when we were writing a lot of this report, it was actually during the 2022 summer heat waves in the UK. And I remember thinking at the time just how timely it was that I was writing a section called Too Hot to Work, Too Hot to Think. And a bit ironic. I'm just going to go into a bit about how and why heat impacts us, because I think that's important to lay the groundwork into why we need to be doing things. Heat particularly impacts the already vulnerable groups, so elderly, pregnant people, but it affects us all. We start to sweat, which cools us on evaporation, but eventually we could get heat stress when this mechanism of controlling our internal body temperature starts to fail and we just can't shed that excess heat. And then when that happens, we start to see our heart rates increase, our core temperature increase, and we find it really difficult to concentrate. We may start to feel unwell. We may faint. You can start to see symptoms of dehydration. And then at the extreme end, start to see heat stroke and heat exhaustion occur. And then on top of all this, when it's hot and we're hot, we have an increased susceptibility to minor injuries and illnesses.
Yeah.
As we lose concentration, we take on increased risks. So maybe it's really hot and I don't want to wear my big, thick personal protective equipment properly because I'm trying to keep cool. So you're putting yourself at risk. I'm not saying that always happens, but there is that risk. People make mistakes.
Sure.
We lack the opportunities as well to recuperate overnight. So if the temperatures stay hot overnight, our sleep is impacted and sleep deprivation starts to take hold. So, for example, between May and September 2022, we had several heat waves across Europe. So an estimated 61,000 people die as in either a direct consequence of the heat itself or because of complications due to underlying health conditions. And 56% of these were women, and more than half were over the age of 80. So again, these vulnerable groups particularly impacted. And then it's not just our physical health. I'm very keen to emphasize the impact on our mental health and well-being. So as I said already, we disrupt sleep patterns. People are more irritable. Our cognitive function decreases. And we can see psychological distress and anxiety in individuals. Extreme weather events can foster a feeling of helplessness and a lack of control on our environments. And then physical activity, which we know is great for our physical health, but also has an immense impact on our mental health and well-being. But as the temperatures rise, we can't get outside maybe to do walking or running or exercising. So our engagement there can reduce. Also to emphasize that medications taken to help us with these mental health conditions really start to can disrupt the body's temperature regulation, which can prove fatal. So in the 2021 Canadian heat dome, those with schizophrenia had a 3 times higher risk of dying.
Wow.
And then when you look at the unhoused community, in London, recent research has found that the hospitalisation risk for London's unhoused was 35% more likely when temperatures exceeded 25 degrees compared to 6 degrees. So then to bring it back to industry, it poses a serious risk to those working outdoors in the sun for long hours. Occupations that involve greater physical exertion, like heavy lifting, manual labour, are more likely to be affected as they're more likely to become exhausted faster, metabolize heat less effectively under strain. And again, like I said at the beginning, jobs that necessitate workers to wear heavy clothing and personal protective equipment are also more likely to be affected by heat stress. To look at the Canadian heat dome again, we saw that workplace injuries across various sectors surged by 180%.
Wow.
And that was attributed to, it's a big number. It was attributed to insufficient workplace cooling and a lack of awareness about the risks of heat. So that was a bit about why it's so important and why companies really need to be paying attention to this issue.
Yeah.
So what can they do? In terms of administrative measures, they're really important. It can be simple as monitoring local weather conditions and effectively communicating through early warning systems and heat alerts to workers.
Yeah.
We need a raised awareness about the harmful effects of heat on human health and guidance for the safety of vulnerable groups. So older people, children and pregnant people. More specifically, we need to start to see the scheduling of rests at regular intervals during work hours, promoting proper acclimatization measures, and more emphasis on observing the health status of workers. So providing water, electrolytes, access to emergency services, and really helping our employees have the tools to adapt to those rising temperatures. It's really important for industry to consider the thermal comfort of our employees.
Yeah.
So there's a couple ways to model that, but I think the best is the wet bulb globe temperature, which actually has uses in multiple sectors. So FIFA use it to develop guidelines for cooling breaks in games, and the US military also have similar guidelines using that temperature. And what it is it's a measure of heat stress. So it takes into account the temperature, the humidity, wind speed, and solar radiation.
Okay.
I find it really interesting because it helps to explain why when we're on holiday in shorts with a cold drink on the beach, we find it a bit more bearable than maybe that same temperature in the UK, where the humidity is higher. So, it's the humidity and the wind speed, they play a huge role in how comfortable we feel in a temperature. What's really great about the wet bulb globe temperature is that it can be simulated and physically measured.
Okay.
And through dialogues between employers and employees, we can design strategies for dealing with heat stress that are tailored to the specific needs and different categories of workers, and plotting contingencies in the workplace so they can adapt efficiently. What's great is we're already seeing it happening in some places. So, for example, there's a case study in the report looking at the BP policy on recognising and assessing and controlling heat stress in the environment on pipelines and how they can mitigate for it. They have administrative measures for hydration, cooling mechanisms. They have implemented a work rest cycle for certain heat index values. And those heat index values consider the location of the worker. So are they inside or outside? Are they wearing thick, heavy, flame-resistant clothing? It's simple measures, administrative measures that can be developed within workplaces with the right support that can really make our workers happier and healthier. And at the end of the day, a happy and healthy workforce works safely and they work more productively. And that's what we all want at the end of the day.
Totally. And as you were talking there, I was thinking back to my days when I had a short stint on an oil refinery. And although we didn't have many hot days, being in, as you said, fire retardant overalls, donkey jacket, hard hat, big boots, the drive to remove some of those in order to cool down in some of the very hot locations within the refinery was very tempting. And so you're absolutely right. Being able to provide the right clothing and the right environment for people to work, or to step away from that, is vitally important, isn't it, for industry?
Yeah, and I think we didn't really go into the report too much, but I think there is work going on about how we can maybe get the same level of fire retardant clothing, but have it lighter. So have like a summer uniform almost for those employees, so that they're not wearing so thick clothing, but they're still getting the same protection.
Yeah.
I think it's a very interesting area. We didn't really go into it too much, but it's definitely something that should be looked at as a possibility.
Yeah, it sounds like we've got a lot to learn from other sectors as well. You touched on FIFA and the sport organisations that are looking at how to maintain healthy environments for athletes, and also I guess where we can learn a lot from Formula One with flame retardant clothing and things like that have to be lightweight in order to take part in the race. So there's an awful lot. I think we can go much further, can't we, to look at how other industries are coping in these environments and apply those to certainly to our heavy engineering community.
Yeah, definitely.
Tim, that kind of leads me on really to my next question, because there must be some way that companies and industry can mitigate some of these extreme temperatures. I mean, but I'm guessing this is not just a case of sort of sticking some air conditioning up in a factory and hoping for the best. What kind of technologies are presently being developed or are available that can reduce these temperatures in industrial plants?
Yeah, so you're absolutely right. It's a lot more than just sticking some air conditioning in a factory. We sort of have to step back and have a radical relook at how we go about providing cooling capability and capacity within our industrial plant and factory buildings. One of the things I want to emphasize is that any approach we take and any route, that any solution pathway that we want to put in place, clearly kind of in the current context needs to be sustainable.
Yeah.
And further, as part of that, it needs to be a low carbon or preferably a zero carbon solution, or even a net zero solution, but preferably zero carbon solution. So, sticking an air conditioning into a factory causes us a bit of a headache around sustainability and in particular reducing carbon emissions, particularly if we're looking at that air conditioning unit being installed in a factory in a part of the world where they're still heavily reliant on fossil fuel for their grid electricity. So, we need to step back and have a radical rethink about how we cool industrial plant and how we cool industrial buildings. And that really needs us to apply, two aspects to our thinking. One, we need to align ourselves with the energy hierarchy, which the institution developed a number of years ago now. In which we laid out a decision-making tree really for how we approach energy use, starting with energy conservation, so not using the energy in the first place, and working our way through passive approaches and then through to through ultimately to the use of renewables. And then, if we absolutely must, mitigated fossil fuels using sort of carbon capture and storage and stuff. So aligning our cooling expectations with the energy hierarchy. And then secondly, we have to take a whole systems level view. So instead of thinking in silos and just looking at, solving this little bit of cooling over here that's causing a headache at the moment, as a designer or as a plant operator, we need to step back and look at the whole system and decide, what is the optimum solution that is sustainable and zero carbon for our plant. So exploring that a little bit more, if you think about any industrial site, you've got the buildings and you've got the equipment and plant. And in terms of the buildings, unfortunately, industrial buildings are not designed in a particularly how can I put this, sophisticated way.
Yeah.
I don't want to be disparaging, but their design is on a kind of a lower, more basic level than designing, for example, a state of the art office block or accommodation dwelling.
Yeah.
So industrial buildings are usually less resilient to heat impacts, simply because they often use dark materials, so that they haven't got reflective surfaces that would help reflect the heat away from the building, the solar gain away from the building. They don't really consider using shade to reduce the solar gain. Don't really think about the orientation of the building to the predominant breeze, to help use natural ventilation to cool the space, to sort of optimize all those passive techniques before moving on to resorting to some sort of mechanical process system that is underpinned by energy use. So there's a lot that can be done around that. And if you think about a typical factory, it doesn't necessarily have a ceiling void and a roof space. It's simply got the roof, and then it's the factory floor. So the heat gain can be enormous. So there's a lot that can be done there. Better design of factory buildings to take into account what can be done passively before moving on to using mechanical process and energy intensive processes for cooling is really important. And then looking around the site to see whether there are sources of cooling that that come from the industrial process that could be used. So reusing waste sources of cooling, or indeed waste heat, undertaking heat recovery to drive cooling processes like absorption is a good starting point. Or using natural resources that are nearby. So if you've got a large body of water that can be used as a heat sink, then using that water to cool the building. If you've got an underground aquifer nearby, using that to cool the building, by tapping into that. So looking for those natural resources and those waste resources, again, before moving on to mechanical systems that are energy intensive. And then, of course, if you do have to move on to those mechanical systems, then trying to power them with low carbon or zero carbon grids, or local sources of renewable energy, biogas, for example, produced from waste or farm manure or whatever, or using more traditional renewable sources like solar or wind to drive to produce the electricity to power those systems. So lots there to be done to make buildings more sustainable. And then with the plants themselves, it's a similar kind of process, but slightly different in that, we need potentially to think about operational changes, so the way in which we use the plant and the processes that are undertaken to help us cope with these higher temperatures. So what I'm thinking about there, of course, is we can change shift patterns, so that the plants are not being operated at the hottest part of the day if they work on a batch process rather than a continuous process. There's scope for thinking about the design of plant layout. So what you often find is that because these high temperatures haven't been an issue in the past, that plant can often be designed with, the outlets from cooling facilities impinging on other processes, so raising their temperature anyway.
Right.
But then when you get these extreme events becoming sort of untenable levels of heat. So you're thinking about the designing of the plant layout, again, in a similar way to the building, thinking about how you can use passive design approaches to make to reduce the heat gain of the industrial plant themselves. So using shading and orientation of plant elements to sort of try to maximize the use of the natural environment before you need to use cooling. And then again, thinking about natural and waste cooling. So for example, with waste cooling, you think about there are a lot of processes that give off cooth, as we might call it. If you think about LNG regasification, so LNG is effectively packaged in cold to bring it from wherever the gas was sourced to wherever the gas is going to be used.
Yeah.
And then when you regasify the natural gas, then a lot of very low temperature cooling is given off during that regasification process. So capturing that co-locating plant with LNG regasification facilities enables industrial processes to tap into that waste cool, as it were. Heat recovery, the heat being used to drive cooling processes, and again, the use of renewables for if you're going to need electrical power. So what you have to think is you have to sort of step back and think, well, two things really. Firstly, let me have a look at this whole system.
Yeah.
So if I'm putting an air cooler on a site, what I look at the whole system. Then firstly, what's the optimum orientation for that, and how does it best fit within the design of the plant layout, so that it's not causing any difficulties for any other part of the plant or the workforce. And then more broadly, how can we maximize the relationship between the various plant pieces to optimize the energy use from one plant to another. So whatever is waste to one plant can be energy to another plant. Yeah. And then I just want to sort of make one last point there, because that's a lot of things, and there's a huge amount in the report around this. There's sustainable sort of net zero carbon cooling was a major theme of the report. There's a huge amount that can be done there. But one of the points I would just want to raise, which engineers often kind of raise when you're talking about this issue, and I think it's interesting just to explore for a moment, is that they typically would say, we typically say, well, surely we're already designing facilities in hot climates. And all we have to do, so think of the Middle East, for example, or Africa. All we need to do is to take those designs and apply them in the more temperate zones that are becoming hotter. Now, that seems like a logical sort of argument, but what that misses is two things. One, the economic impact of doing that, and whether the business model will still stack up. And then the second is the fact that the design envelope just becomes enormous. So if you think about, okay, let's take the first one of that, the economic dimension. If you're in a Middle Eastern country and you simply tackle the temperature by increasing the amount of cooling you've got, so increasing the number of air cooling units or water cooled units or whatever your main cooling type is, what you do is you increase the footprint of the plant. The plant can be 1.5 times larger than you would typically find in the UK or Canada, for example, and you increase the energy use dramatically of the plant. Well, that's fine if you're in a Middle Eastern state that can just burn more fossil fuel, because you literally got it there in the desert around you. And of course, the labor costs in building that plant are much lower often than you would find them in a North American, North European or Japanese economy or whatever. You start to ask questions then about whether the business case stacks up, because all of your capital costs and operational costs are predicated on the energy costs and labor costs, etc., within the country you're operating in, and then of course the footprint also has societal issues, particularly where you've got restrictions on land use. So you can't just build it half as big again or double the size it is to cope with the additional cooling capacity required. UK planning just would really struggle with that. So and quite rightly so, because we've got limited land and it's needed for a lot of other things. So it's not simply a case of transferring it. Now, the other aspect is what we have to realize about climate change, particularly in the next few decades, as the climate transitions into something new, is that we're still going to get some very cold winters, and we're still going to get severe, very low temperature winters, as well as these extreme high temperatures. So what that does is it extends the design envelope of the plant from say -15 to +45 or +50, which is an envelope that we've just not had to design for before.
Yeah.
And designing for that has huge sort of economic implications, because solving those issues about how can I be ensured that my plant is going to work at -10 or -12 at one time of the part of the year, and then it's going to have to work at 45 degrees C above at another time of the year. So that affects choice of materials, safety systems, all sorts of things. So, and the performance of the process itself. So that has quite a large economic impact. Whereas in a lot of these hotter parts of the world, they're hot already, and they're just going to get a little bit hotter. Yeah. So, or a lot hotter in some cases, but there's still the design envelope's still going to be between, say, plus 30 and plus 55. So that you haven't got to deal with those sort of extremes of cold. So they're the two main issues there around how we think about how we tackle industry. It's not as simple as just transferring existing technology and design processes from one part of the world to another.
Yeah, we've certainly got to learn, haven't we, about the locale that we're in and understand, as you rightly say, the system in which that business, that company, factory is going to operate in, and understand that environment before we can start to just drop pieces of technology in without any regard. Yeah,
and you're absolutely right, Helen. I mean, it's that whole systems level approach where we as engineers have a terrible habit of just diving straight into the technical aspects and the calculations, and without thinking about the entire ecosystem that our solution sits within. So, the whole landscape of, the policy landscape, the social landscape, the cultural landscape, the natural landscape, everything that surrounds and impacts on that solution and that solution impacts upon. And that's what I mean by, and you were meaning there by a whole systems level approach. Yeah. And it's that's the only way we're going to tackle this problem.
Yeah. And it sounds to me as well, Tim, that the thing that came to mind when you were talking about those really big extremes of cold temperature and hot temperature, we're going to have to learn a lot from other technical industries, aren't we? For example, like the space industry, who have to deal with those real extremes of temperature in space. That there's a lot that we as engineers can learn from other industries to try and bring those down to kind of a terrestrial level, I suppose.
Yeah, absolutely. And the transfer of knowledge from one sector to another is again another key role for the institution. We have memberships that work across lots of different sectors, and getting together and exploring how we can take solutions from one sector and use them in another sector without having to reinvent the wheel is a really a core part of developing a successful outcome to meeting these challenges.
Laura, within the report, you have identified some critical steps and actions that need to be taken to manage these extreme climate events while enabling industry to keep up with demand. What recommendations have you made to policymakers and government in this regard? And how do you see the IMechE's work as a leading voice in policy galvanising political change?
We made a number of recommendations in the report. So we had a set focused at industry and what they need to do to develop and implement adaptation plans for buildings, people, equipment and plants. We had a set towards the engineering profession, really calling on engineers to help industry prepare for the impacts of increased temperatures. A set aimed at academia and skills development bodies to ensure basic climate change knowledge is taught at every level, and that the curriculum starts to incorporate impacts of rising temperatures, approaches to adaptation, principles of net zero design, resilience, circular economy. But I think the big set was rightly aimed at government policymakers around the world, and we emphasised the need to recognise the potential productivity impacts of higher ambient temperatures and extreme heats on industry, because these sectors underpin our national and local economic well-being. So we really need to see that support from governments to help industry adapt, to make sure that we are staying at the same productivity levels, because we are going to need to adapt to these new temperatures. It's not just a UK problem, this is a global problem. So the recommendations looked at perhaps raising awareness of the projected heat-related impacts of climate change on industrial assets and buildings, and really asking governments and policymakers to encourage owners, developers, financiers, lenders, and those involved with the design and construction to take on urgent action on adaptation. We think the planning policy should consider the evaluation of existing planning requirements for new builds and retrofits to reduce exposure to climate change induced heat impacts, and make sure that the buildings we're building now and the buildings we have are fit for the future environment. I think it's really important that any building we're currently building, whether it's an industrial building or it's a house, we're considering we want this house to be here for 30 years. Using historical data isn't necessarily going to be useful because our climate is changing so rapidly. We need to be using the future climate projection to say in 30, 40, 50 years, this is going to be the temperature and we're going to see this many extreme hot days, this many rainfall days. So let's design for that and not necessarily design for now.
Yeah.
So it was really important that we urged in the report that there's a review and update of building codes and regulations to ensure that they are relevant for higher ambient temperatures. And we were really happy actually to see in the National Infrastructures Commission's second National Infrastructure Assessment, bit of a tongue twister, which was published this month, that there was a recommendation that government should work with the relevant standard bodies to identify and update core technical engineering standards to factor in future climate change. And that was really great to see.
Yeah, absolutely.
The recommendation in our report also emphasised the development of an energy policy vision for industrial cooling that's not just defined by electricity. So we're not just saying plug in an air conditioning unit all the time, but based on the fact that the provision can often be better achieved by thinking thermally and utilising thermal resources. We have also urged governments to encourage high hazard industry regulators to mandate operator assessments of extreme heat risks alongside other climate threats within their licence to operate application, and carry out those gap analysis between the original design specifications and the more recent future climate projections. We've been in touch with the Environment Agency on this and progress is being made, but it is really important that the climate projections are easily accessible, usable and relevant to industry. There's no point if they can't use it. We need to have that data accessible. Sure. So again, in the second National Infrastructure Assessment, there was a recommendation that the Met Office infrastructure operators and appropriate regulators should work together to develop an accessible interface for asset owners to use relevant climate data. So again, we're moving in the right direction there, and it's really great to see that a couple of the recommendations are already being picked up, which is, I guess, fantastic. As for the institution, as you know, we represent a global community of over 110,000 engineers across diverse sectors. So it's really put us in this unique position to really facilitate the collaboration amongst industry, academia, governments, and leveraging the collective knowledge and expertise of our fantastic membership. Yeah. So specifically, our commitment to addressing climate challenges is exemplified by this report, if I do say so myself. It feels like a pat on my back. But I think what was great about it was that we weren't limiting it to a regional context. The recommendations are relevant globally, and it is on us as well to make sure these messages are translated into actionable initiatives and engaging with stakeholders. So like I said, we've already seen it here in the UK, but we need to make sure it's picked up beyond just the UK. So beyond the report, we had a series of blogs over the summer looking at different aspects of heat. In September, we convened a highly successful international conference workshop on climate adaptation and resilience, which brought together civil servants, industry leaders, researchers from various corners of the world to discuss adaptation and resilience strategies in the face of not just heat waves and droughts, but pluvial and fluvial flooding and sea level rising and coastal flooding. So we had participants from France, India, Japan and Kenya, and we had a really vibrant and great discussion looking at future research angles. And by having these global participants, it meant that when we were talking about future work, future research that could be picked up by the participants of the conference, everything had a global angle to it.
Yeah.
So it meant that, again, the solutions that were being proposed at that workshop and conference weren't just UK centric, which I think is really great. And we're looking to hopefully do a repeat of that at some point in the future. So yes, progress is evident. Lots of work remains. We were pleased to see the Environmental Audit Select Committee in the UK House of Commons launched an inquiry in September, I think it was, into heat resilience and sustainable cooling. As an institution, we remain committed to being actively engaged in this dialogue, advocating for the review of planning policies, the updating of standards, and the establishment of energy policy standards for industrial cooling. So we're going to continue to be involved in that dialogue. At the core of our mission is the development and training of engineers. So we are looking at making sure engineers globally are equipped with the foundational principles of net zero emissions, circular economy principles, sustainable design, which means we can then really exemplify the impact of engineers in contributing to a sustainable and resilient world. So yeah, that's on our radar. Something we're going to be implementing and looking at in the next couple of months is how we can incorporate those into our degree programs.
Yeah, I mean, that last point you touched on is vitally important. And it comes back to something you said right at the start of that, which was that this is not just about solving a problem right now. We're already in a crisis, aren't we? This is about making sure that we are fit for purpose for the next 50 years, next 100 years, if possible. And planning ahead is what engineers are very good at. The opportunities to embed this not just into our educational system, but to help that to drive change within the political circles is going to be key to ensuring that we provide a safe and fit environment for people to not just work in but live in as well.
Absolutely. And I think often you hear people say adaptation is the less cool part of mitigation. But I think you need both. We absolutely should be looking at mitigating and limiting the temperature increase as much as possible. But we need to be realistic.
Yeah.
If we just look in the UK and stay UK focused, the temperatures here have already changed so much that we can't ignore it anymore. We really need to see an increased focus on adaptation. And they go hand in hand. You can't do one thing to adapt to climate change that could then make the mitigation harder.
Yeah.
So if everyone's to install inefficient air conditioning units, that's not going to help the fact that then we've got to mitigate even more. So the challenge becomes even greater, which means it becomes a bit of a vicious cycle. So we really need to get both sides of the coin talking a bit more and having that emphasis on, I guess it's a pragmatic approach, really. It's we are where we are. This is the situation. Let's try not to make it worse, but let's acknowledge that it's not great and do something about it and think for the future rather than just be reactive all the time.
I think that's a really great point to make, Laura, and something that we as an engineering community really need to get behind. That leads me on to another question in terms of the technical challenges we are going to face and what the engineering community, as you rightly said, we're always trying to find solutions to these problems. So what kind of technologies are we going to see develop over the coming years? Clearly, there's an awful lot of work to be done to try and improve on those. So how is that going to help us kind of reduce or capture or reuse heat? And how's that going to trickle down into wider society, that residential properties, for example, could use and learn the lessons from manufacturing?
Yeah, so there's a lot going on, Helen. There's a huge amount going on.
We probably need another podcast for that, right?
yeah, but let me just give you sort of a flavour. I mean, I want to say straight out of the gate, though, that we already have a lot of what we need to sort of start tackling this situation without developing more technologies and more approaches. The key is really about this issue that we were just talking about taking a systems level view and transferring knowledge from one sector to another. So that's the first thing I want to say. But because we, again, as engineers, we tend to like to look for the sort of the shiny new, sexy stuff that kind of allows us to get very innovative. Whereas there's a lot that needs to be done around being innovative in terms of transferring knowledge from one sector to another and adjusting it for that new sector. So that's my first point. But coming on to the shiny new sexy stuff, I mean, the first one that comes to mind, of course, is artificial intelligence and the role that can play in helping us integrate and optimize cooling systems and their performance. There's a lot there that will help us in sort of predicting our cooling needs, adjusting operations in real time, anticipating issues and identifying areas where efficiency can be improved. There's a huge amount that artificial intelligence will bring to that. And I find more and more as I go to adaptation focused events and discussions and meetings, the role that artificial intelligence can play is just coming up over and over again. So there's a lot certainly that we can do there, and that will help also potentially with sort of knowledge transfer from one sector to another. Nice sexy things in cooling are things like radiative cooling, which involves sort of special materials that emit thermal radiation in particular spectra.
Right.
And can help produce new ways of developing cooling. So just sort of imagine a solar thermal panel in sort of reverse, but instead of radiating heat into the local environment, it's radiating across a particular light spectrum into space.
Okay.
So using space to cool the process effectively. That's nice and sexy and exciting and shiny and new. And there's some really good work going on in that. And it's been proven at small scale, at very small scale, laboratory and sort of very small pilot scale. But, a lot of interesting, innovative work that, to be done there. How exciting is that? You've got things like phase change materials. They've been around for a while, but there's still a lot of work to be done on phase change materials. So, materials that can, very cool spaces in the day as a result of sort of absorbing coolth in the night. There's a lot of potential for building that into buildings and plants. So, so there's good work to be done around that. There's the issue of or the opportunity of magnetic refrigeration.
Okay.
Again, that's a new area. It's promising alternative to the sort of traditional vapor compression refrigeration that we currently use.
Yeah.
They've got potential to be more energy efficient, environmentally friendly. There's a lot of work going on dehumidification technologies that can be used to provide cooling. Reversible heat pumps, these kind of devices, and a lot focused on starting to build sort of hybrid and multimodal cooling systems. So,
right, okay.
Not just thinking about a cooling system that's composed of one element, but bringing together a group of technologies that work synergetically together to sort of, produce a more flexible cooling system.
Yeah.
So, that sort of brings together, in many cases, passive cooling with mechanical, more energy intensive cooling. So there's a huge range to go, and like you say, I mean, that could literally be a podcast of its own. So probably that'll do for a starter for 10 there.
Yeah, I mean, it sounds fascinating, and it's certainly, as you've touched on already, it's bringing together different aspects of engineering, particularly materials. I mean, that's where we're really going to find some fantastic solutions, I think, isn't it? In terms of how we can store and capture and then reuse the waste heat or the cold to be able to manage the thermal environment we're in. That sounds really exciting to me.
Yeah. Yeah, and more. I'm more turned on by radiative cooling and artificial intelligence. Every engineer has their own particular nuanced passions.
Yeah, absolutely. Well, I'm going to be trying to do my best. I'm refurbishing a house which is going to include solar and air source heat pumps and other technologies to try and mitigate the amount of heat we use and the energy we use as well. So hopefully I can incorporate some of these new technologies, Tim, that you're referring to. That would be really exciting from my point of view.
Yeah, and do make sure that you consider what your future cooling needs are going to be, because most people are not doing that at the moment. So
yeah, absolutely.
Have a look at the climate change predictions for wherever you are, and what sort of temperatures you're likely to see in the future, and do make sure, because at the moment cooling is in countries like the UK is the sort of Cinderella and is an afterthought, whereas increasingly cooling is going to become more important than the heating element.
I will bear that in mind as I start the process of converting this rather old house into a new technology-driven property. So thanks for that, Tim. I will bear that in mind. Thank you for sharing the details of this report, which we'll put into the notes on the podcast. And I'm so pleased to hear that the report has already had a significant impact here in the UK. And let's hope that it's taken to heart by many communities across the world, because I think this is fundamental to us as an engineering community driving change. So thank you to both of you for talking to me today. It's been a real pleasure. Thank you.
Thank you so much for having us.
That's all for this month. In next month's episode, we will be following on from our Climate Adaptation podcast to talk about the global issues of energy use and how engineers around the world are addressing the problem. Members of the institution working in the energy sector in China and India discuss the differences between the East and West's response to climate change and what actions these two countries are taking to mitigate over-reliance on unsustainable energy sources across their vast land masses. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.